To solve a system of linear inequalities, we want to determine the region that contains the ordered pairs that would satisfy both of the inequalities, where each ordered pair consists of one x and one y value. To do this, we'll graph and shade the first inequality, graph and shade the second inequality, and then determine the region that is shaded twice. So for the first inequality, because the inequality symbol is less than, we'll have a dashed borderline, and we'll graph the line x minus 3y equals 6, keeping in mind that it's dashed. And because this line is in standard form, we'll graph this line by determining the x and y intercepts by completing a t-table, where if we set x equal to 0, we'll determine the y-intercept, and if we set y equal to 0, we'll determine the x-intercept. Notice if we have x equal to 0, the equation is just negative 3y equals 6. So if we divide both sides by negative 3, we would have y equals negative 2. And then if y is equal to 0, notice how we just have the equation x equals 6. So very quickly we have enough information to graph this line. The y-intercept is negative 2, that'd be here. X-intercept is positive 6, that's here. And our dashed borderline passes through these 2 points. And then we'll pick a test point to see whether we should shade above or below the line. Let's go ahead and test the ordered pair 0, 0, or the origin. Notice that if we have 0 for x and 0 for y, we have 0 is less than 6, which is true, which means we'll shade the same side of the origin, or in this case, above the line. But because our ultimate goal is to determine the double shaded region, I'm just going to draw arrows here to indicate which side of the line that we're shading. And now looking at the second inequality, notice that the boundary line would be solid because the inequality symbol is less than or equal to. So we have a solid boundary line, and now we'll graph the line x plus 4y equals 4. And again, because it's in standard form, we'll go ahead and complete a table of values, or t-table, and determine the x and y intercepts. So we'll let x equal to 0 to determine the y-intercept, and then we'll set y equal to 0 to determine the x-intercept. Notice if x is equal to 0, we would just have the equation 4y equals 4, so y would have to be 1. And if y is equal to 0, we just have x equals 4. So now we'll plot these 2 points, and then graph our solid boundary line. So again, the y-intercept is positive 1, this point here. The x-intercept is positive 4, this point here. So we have a solid boundary line passing through these 2 points. And then to determine where to shade, let's go ahead and test the origin again. So we'll substitute 0 for x and 0 for y. Notice how we'd have 0 is less than or equal to 4, which is true. Notice how the origin here is below the line this time, and this ordered pair did satisfy the inequality, so we're going to shade below the red line. And you can see that the double shaded region is this region here on the left. So we'll go ahead and shade this as the solution to the system. Again, which means that any ordered pair in this region would satisfy both of the inequalities, and it also includes this boundary line, but it does not include the blue boundary line because this is dashed. I hope you found this helpful. We'll take a look at one more example in the next video.